Okay, welcome back to another AIM math class. I don't know why this is, there we go. Why is it highlighted? Okay, anyway. So guys, today we're going to take a look at equivalent expressions using the distributive property and combining like terms. So we've talked about this a little bit, but what I want to talk to you about today is just a quick review of like terms and the distributive property. Hey, there's my daughter. Say hi. Well, I think she's mad. But that's okay. Let me pause. Okay, I'm back. It was an emergency. Her brother was spinning her in the swing, and she didn't want him to do that. Anyway, so let's take a look first at some terms here. So on my board, I have three terms. So you'll see that I have a negative 3x plus 5x minus 7x. And as you think about that, you're going to see that the first term, negative 3x, and the positive 5x, and the negative 7x, or you could think of this as minus 7x. These are all like terms because they have the same variable and the same exponent. Okay, so I've circled all of the terms here, and we're going to put them together. So we're going to think, kind of left to right. So we're looking at the coefficients only. So negative 3 plus 5. So I'm negative 3, or 3 below 0, and I'm adding 5 to that. So negative 3 plus 5 is going to leave me at positive 2x, So negative 3 plus 5 is positive 2. Now I'm going to go from positive 2, and I'm going to either think of this as adding negative 7 or as subtracting 7. So if you can imagine us being at positive 2 and taking away 7, positive 2 taking away 7, we would now be below 0, and we would be at negative 5x, or negative 5 below 0x, negative 5x. Okay, so the final answer would be negative 5x. Now, what I want you to think about is that the original expression, negative 3x plus 5x minus 7x, is equivalent to negative 5x. So these are called equivalent expressions. So what we did there is we combined like terms, Okay, second example, I've got on the board here 3 times 4x minus 2. And so this is an example of us using the distributive property to create an equivalent expression. In other words, I want to make another expression that is equivalent to this one, but maybe is in a different form. So what I'm going to do is I'm going to multiply or distribute the 3 out to the 4x and distribute the 3 out to the negative 2. So what I have here is I've got 3 times 4x. That's going to give me a 12x. And I know you can't see this right now, but that's okay. And then I'm going to say 3 times negative 2. I know that a positive times a negative is a negative. So 3 times negative 2 is going to give me negative 6. And because it's negative 6, I'm going to write this as 12x, where's it at? 12x minus 6. 12x minus 6. So again, I did the 3 times 4x, and then the 3 times negative 2, and I got 12x minus 6. That is a funny looking 2, but that should be a 2. I'm going to rewrite that 2 because it's not pretty. A 12, that's better. 12x minus 6. So again, the 3 times the 4 gives me the 12x, the 3 times the 4x gives me the 12x, and the 3 times the negative 2 gives me the negative 6. Now, what I want you to know is that the first expression, the 3 times 4x plus 2, and the second expression, 12x minus 6, these are equivalent, which means they are the same expression, but in different forms. Okay, next example, I have 9x plus 6, and what I want to do is to create an equivalent expression, but this time I'm going to work in reverse. So I'm going to be doing like factoring. So instead of distributive property, I'm going to factor out a common factor. So I'm going to look at the 9x and the positive 6, and I'm going to think to myself, what can I divide out of each of these terms? What do they have in common? What is the greatest common factor? And so when I think about that, I think about the fact that 3 will divide into 9, and 3 will also divide into 6. So I'm going to divide these both by 3. So I'm going to create my parentheses. 9x divided by 3 gives me 3x. 6 divided by 3 gives me 2. So 3 times 3x plus 2 is the same as 9x plus 6. These are equivalent expressions, okay? They are equivalent, which means they are the same, but just in different forms. If I wanted to test this out to make sure that they were equivalent, I could distribute. I could say 3 times 3x is 9x, and I could say 3 times 2 is 6, and I see that they are equivalent expressions. Okay, guys, last example. What we're going to look at now is actually number 12 that is on the worksheet that I have projected on the board here, or I'm sorry, projected on the computer screen. So we are going to simplify this expression by taking a couple of steps. One, we're going to distribute first, and then we're going to combine like terms. So the first thing I would do is I would distribute the -5 times the a and times the -6 or the -6, okay? So -5 times a is going to give me -5a, so I'm going to write that down. That's going to give me a -5a. So I distributed this out and got a -5a. And now I'm going to do -5 times -6. Now, a negative times a negative is equal to a positive. And so that's going to give me positive 30. Positive 30. And so now the last thing we've got to think about is this positive 2a that is already here at the end. So what do we do with that? Do we multiply that times the -5? No, because the 2a is not in the parentheses. So we just drop the 2a down. And so that's what I'm going to do. I'm going to drop the 2a down. So I've got plus 2a, plus 2a. So this would be like partly simplified. I've got -5 plus 30 and then plus 2a. And so now I need to now combine like terms. So the only thing I can put together, notice I've got a -5a, I've got a plus 30, and I've got a plus 2a. So this plus 30, this is a constant, so it cannot go together with these a's here. So I'm just going to consider the a. So -5a plus 2a. So I'm 5 below 0. I add 2, so I'm getting closer to 0. So I would be at -3a. So I would have -3a plus 30 as my final answer. So -3a plus 30. -3a plus 30. And I'll put that in front of the screen. -3a plus 30 would be my final answer. Simplified. So that -3a plus 30 is equivalent to the previous expression, which was -5a plus 30 plus 2a. It's also equivalent to the original expression, which is what we see on number 12. Now, this was very short and straightforward. It is review. This is to prepare you for the Freckle assignment that you have next. There also is a Khan Academy video that is linked as well. So guys, thank you and good luck.